Welcome to Spring LIB.
Quinoline and indole both undergo electrophilic aromatic substitution, but they exhibit different properties. For example, in the quinoline case, the electrophile will be incorporated into the ring that does not include the nitrogen, whereas in the indole, the electrophile gets incorporated into the nitrogen-containing ring. The reason for that is we can certainly see in the indole is that the 5-membered ring with the nitrogen is an aromatic ring, but it's 6 electrons in 5 orbitals, or over 5 atoms, whereas the benzene ring on the other side is 6 electrons in 6 orbitals, or 6 electrons over 6 atoms. So the 5-membered ring in the indole is more electron rich, which means there's a greater attraction for a positively charged electrophile. In the case of the quinoline, we have 6 electrons in 6 atoms, or 6 orbitals on both rings. So, and the nitrogen, because of its placement, is not engaging in any additional resonance. In other words, the electron pair on the nitrogen is not being delocalized. It's in an sp2 orbital sticking out to the side. It's not part of the p system or pi system. So there's no additional resonance. So that means the only effect this nitrogen is having is through its inductive effect based on its electronegativity. And the inductive effect of the nitrogen is going to be stronger on the adjacent ring carbons than it will be on the carbons in the other ring, the 6-membered carbocycle. So that means the other ring is where the electrophilic aromatic substitution will take place preferentially. Now, the other question is, why does the placement occur where it does? For example, in the quinoline, why is it at carbon 8 instead of carbon 7? Well, if we look at some resonance structures of the quinoline, all I've done is taken one of the pi bonds and localized the electrons on one of the atoms. So in this first resonance structure, the electron pair is localized on carbon 8. And there's a positive charge then that can get delocalized around the ring system. And if you draw all the resonance structures, this plus charge never lands on the electronegative nitrogen. It's always on a carbon. However, if we compare that to a resonance structure where I've localized the electrons on carbon 7, when we delocalize the positive charge around the ring, eventually we will bring it to a place where the nitrogen will be carrying the positive charge, but it will be a nitrogen with only 6 electrons around it. It will not have an octet. It will not be quaternary or having 4 bonds. It will only have 2 bonds, an electron pair, and the positive formal charge. So that's an unstable situation. So the resonance structure that does not have the plus charge eventually getting onto the nitrogen atom is less unstable. So where the negative charge is localized on the ring is where the electrophile will primarily form its bond. In the case of the indole, we can draw a resonance structure where we do delocalize the electron pair from the nitrogen because it is part of the p system or the pi system. it's not sticking out to the side in an sp2 orbital. So we can delocalize it, and when we delocalize it, we do get a nitrogen with a positive formal charge, but this nitrogen has a complete octet, and that's okay. Um, and the electron pair then is localized on carbon 3 of the indole ring, so that's where the electrophile will preferentially attach.